In this section, we are going to talk about ownership, references, and borrowing. We are going to cover what moves, clones, and copying is, as well as looking at how the ownership model works when dealing with functions. It is important to understand the ownership model because it is the basis for how the memory model works for Rust. The concepts we cover in this section are going to be with us for the remainder of the course, and it is also going to influence how we write our code. So, without further ado, let's dive right into it. When we talk about memory, we, as programmers, like two things. We want our memory to be given back to us at a time of our choosing, and we never want to reference memory once we have given it back to the system, because if we do this, then it causes undefined behavior and can lead to crashes and security holes. In 2019, Microsoft Security Response Center reported that roughly 70% of the vulnerabilities they assigned to a CVE each year continued to be memory safety issues. So memory safety is a big deal. Typically, programming languages have done two options. The first one is garbage collection, which Java, C#, Python, JavaScript, and so on all have. With a garbage collector, programmers give up having control over when objects are freed to the collector. The second is through manual freeing of the memory, such as what is done in C and C++, which is great if you never make a mistake, but history says programmers are likely to make a mistake. So what does Rust use? Well, technically neither. Rust uses an ownership module, and ownership is Rust's most unique feature. Rust compiler is going to verify that your program is free of memory safety errors, such as dangling pointers, double freeze, using uninitialized memory, and so on. This concept is what drives the Rust language, so it is important to understand the reason behind this design choice. So let's start looking at what ownership is, because it is a new concept for most programmers, so it does take time to get used to. But the more you use Rust and become familiar with the rules of ownership, the more natural you will begin to feel with the concept. Let's quickly talk about the stack and the heap, which are parts of memory. The stack is going to store values in the order it gets them and removes the values in the opposite order. So it is a last in, first out. A great example of this is a stack of plates. You add to the top, but then you also remove from the top. All data stored on the stack must have a known fixed size. Data without a known size at compile time or a size that may change will be stored on the heap. The heap is less organized, and when you put something onto the heap, you request the space, and that will then return a pointer, which is the address of that location. Pushing onto the stack is faster than allocating on the heap, so searching for data on the stack is also faster than searching the heap. When you pass values into a function or have local variables inside the function, they are all pushed to the stack. And then when the function is over, they're popped off the stack, which is the same thing as removing them from the stack. So I mentioned earlier the rules of ownership. But what are they? Well, the rules are each value in Rust has a variable called its owner. There can only be one owner at a time, and then when the owner goes out of scope, the value will be dropped, also known as freed. So let's start off with a simple example and just start trying to understand what these concepts mean. So for the first one, we'll say let var equals 1. So in this case, var is now valid for the rest of the main function, and since we know that the value 1 is of I32 or U32, in this case it's I32, it has a fixed size. So we know that we're getting pushed onto the stack. But now, say we're down here now, var is dropped because the main function is over, so we are freed from memory. So same thing with strings. Strings can change in size. So we're going to do a mutable string called s, and we will do hello to string. So now we have the S variable, which is a string called with the data hello, and this is going to be created on the heap. Created on the heap on the stack. So just like down here, now that we are no longer in the main function, S is also dropped, and the resources are given back to the operating system. So now we can push a string on here and just say hello world. And what this is going to do, it's going to append world at the end of hello, which we can do because we are allocated on the heap. And that means we are able to grow. So in the following lectures, we are going to dive into these mechanisms that drive ownership. Alright, so now let's talk about what a move is. A move sounds exactly like what it is called. When you do a move, you move the ownership of the value from one variable to another. And most types implement a move. So let's see an example of this. We're going to create a vector, name it x, and we're going to just store in a string that contains the value Tyler. And then we're going to create a new variable called y and assign it to x. And now let's see what happens when we try to print out what x is. So this will error out, and it's actually already telling you like, hey, this isn't going to work. Okay, so it says here, we borrowed the borrow of a moved value x. So it's saying that our move occurs at line 7, or line 8, excuse me, and then we try to reference the value that got moved in line 9, which is a violation of the ownership rule, right? Because we gave the value of x to y, and then we tried to reference the value that x had. But x no longer owns that value. Y now owns it. And so the same thing would apply if we said let z equals y. So now if we come down here and now try to reference y, it's going to tell us the same thing. It says the move occurs because y does not implement the copy trait. The value is moved here in line 9, and then we try to reference the borrowed value here after the move. But it's going to let us run and use the z value perfectly fine. So as you can see, now we have Tyler printed out. So that's how a move works. But now, what exactly is a copy? So let's take a look at how we can do deep and shallow copies of these values in the next lectures. In this lecture, let's take a look at what a clone is. So if we want to actually take the value of a variable without taking ownership, we can perform a clone, which performs a deep copy. And what this is going to do is it's going to take the values from the variable we are referencing and copy them into a new variable. Doing a clone may be expensive, but let's check out how it works. So I'm going to take all this code, I'm going to copy it, and then I'm going to comment it out up here, and we're just going to print it down here. So we have the same thing so far, but now we want to do a clone on x, and then we want to clone on y. So now if we do this, and you know what, let's actually go ahead and let's print out all of them real quick, just to make sure that everything works. So we created our vector with just the Tyler string in it. We told y to be a clone of x, and we told z to be a clone of y, which was a clone of x. So now when we run this, we see Tyler, Tyler, Tyler. So what this means is we completed a deep copy of x, and we were able to assign the string of Tyler to y and z. So now as you can imagine, this can be a very expensive operation. Imagine if you have a vector with hundreds of thousands of values in it, and then you try to clone it. It's going to clone every single value inside that vector into the new variable. So, as you can imagine, it is an expensive operation to do. But let's look at what a copy is in the next lecture. Alright, so in this lecture, I want to take a very quick second to go over what a copy is. So I've already set up our example and said let x equal 1, let y equals x, and then we're going to print out the values of x and y. And do you think this example is going to work based on everything that we have talked about leading up to this point? Well, it does, and you can see here that x equals 1 and y equals 1. But why does this work? Well, earlier on in these lectures, I was very careful to say that most types implement a move. Some implement what is known as a copy. And a copy is going to be implemented on types that are already stored on the stack, such as an integer, boolean, float, char. A tuple can also have the copy trait if every value it contains implements copy. So I just wanted to point this out because we have done this before, and I just wanted to make sure it was clear as to why we're able to do it with some types but not others. But after this, we're going to get back into looking into moves a bit more and trying to understand this ownership concept to the best of our ability. Alright, in this lecture, let's take a little bit of a more thorough look at how moves work. So the first thing we're going to do, we're going to create a string and say string from, and we'll say takes, because we're going to take ownership away from the string through a function. So we're going to call this fn takes ownership, and we're going to take a string, and then in here we will just say let string equal s. Okay. So what's going to happen in this is, I guess I should call it, so takes ownership, and we pass in s. And then in here, you know what, we'll print it out, and we'll print out string. So what happens here? So we create a variable with a string takes, and then in here we give ownership to the function, right? So we're taking this variable, giving it ownership inside of this function, and we're using it in here. So if we cargo run it, we can see that we're in here inside this function. So just to make sure that the ownership was taken properly, let's actually, and to be lazy, I'm going to copy and paste, and it's not even going to let us build and run. But again, earlier on in this lecture, we saw these same errors where it talks about how we move the value and then we try to reference the value borrowed after the move. So, good. We can see that we pass ownership to functions when we pass the values through parameters. So, what about passing a value as a copy? So, we'll say let value equals 1, and then we'll do the same thing. We'll just say, hey, how about make a copy of it? Okay, so then we'll call this 1, because that's what we're going to pass in, and we'll just make it of I32, and down here we'll say let val1 equals 1, and we'll print out val1. And then here we will say make copy of val. And we make a copy here because this is an I32 which implements the copy trait. So again, if we run it, we'll see 1 printed out, and the same concept applies what we learned last lecture of when it's a certain variable, some of them implement the copy trait. And I32 implements copy, therefore the function does not take the ownership of it. So we can also give ownership, so we'll say give ownership, and in here we'll do another string 1, string, and we want to pass it back a string, and then we will say given dot to string. Oh, got an error. What do we got? We'll see. So up here we will have let type string equals give ownership. Oh, and we don't want to pass a parameter, and I see what my issue is down below. Get rid of that. Okay, so we called give ownership, which owns given. It owns this, even though it's not technically a parameter, it still owns the value. And we can print it out and show that we now have ownership of it. So, and it was given. So down here we passed ownership back up through a returning of a string. So now we can also do both of them. So we can take and give. So let's do another string. We'll call it string 2 of string, and it's going to return a string, and we'll just do that. We'll return exactly what is given back. So we'll say let string 3 type string equals take and give, but of string 1. So now I expect string 1 to print out given, which it does. And to prove that we took it, let's try printing out string 1 and see what happens. So we already got our error, which is a good sign. So we can see that we are able to take and give ownership through functions. Well, what about with control flow statements? Do they work the same? So let's take a look at that just to see what is going to happen with those. So we'll again keep super simple concepts here, and we'll say let string 4 equals string 3 else, and this will obviously never get run because we have true in the block above, but just for sake of it, string 5 also equals string 3. Okay, so what happens if we try to print out string 3? Well, it's giving us that error. Sounds like a good sign. Okay, let's see what it says. Move occurs because string 3 is type string, does not implement copy. That checks out. At line 35, the value is moved here. So also in control flow statements, ownership operates the same as if they're not there. So you can pass ownership through those as well. And lastly, let's look at a loop. So for this, let's just do a kind of a clean slate. Let's comment all this out. We'll comment all this out to suppress any errors or warnings, I should say. So let's create a mutable string too. And then let's just call loop. And I actually want to, we will give let mut str1 equal string from Tyler. Okay. So a loop. Remember, this is just going to be an infinite loop that happens nonstop. So let's assign str2 to str1. And what do we get? So we also have an ownership issue here. And this is actually really important to note because remember, this is an infinite loop. But imagine if you have a for loop or a while loop, based on some kind of condition. Well, if you change ownership of a variable or a value, I should say, inside a loop, that ownership changes. So that ownership needs to be able to stay alive on that value for the entirety of the loop. Because if you change ownership, you might break the loop, which is what happens in this case, because it says here the value was moved here in previous iteration of a loop. So those are just a couple of more examples of how ownership works. And I did not want to spend as much time typing out the codes as going over the concept, so that was why it was a lot of copying and pasting. But all of these concepts we will practice a lot throughout this course, so I really just wanted to make sure I introduced them just to really emphasize how important these concepts are for understanding the Rust language. In this section, we're going to take a look at references and borrowing. References allow us to make a reference to a value without taking ownership of it, aka we're borrowing the value. We have two types of references, shared and mutable. A shared reference is going to let you read but not modify whatever is being referenced to. You can have as many shared references to a particular value at a time as you desire. Mutable references, on the other hand, allow you to both read and modify the value. However, unlike a shared reference, you cannot have any other references of any sort to that value active at the same time. So let's take a look at this. So we'll start out by saying let s equal string from hello. And then we want to create a function called change string, and we want to take in some string of a reference to a string, and then we want to take some string and push something onto it. Okay. So here we want to say change a reference and then to s. So we make a reference by using the ampersand sign. So we can see we're already getting an error here, and it's telling us, hey, we need to make some string mutable. So the first thing we need to do is say let s be mutable, and then in here we need to make it known that it's going to be a mutable reference, and then down in here we got to do the same as well. So now all of our compiler errors are gone. So let's see what happens when we print it out. And so we're expecting s to come back and say hello world, which is exactly what happens. And we were able to do this because we added the mute keyword, so making it mutable, to the variable and inside the function argument. So after running cargo run, we were able to see that we changed the variable without ever taking ownership of the variable inside the function. Because if we didn't pass it by reference, then change string would have taken ownership of s, therefore s would not have been able to have been used here. So that is the power of references and borrowing in Rust, and it's a concept that we are going to use throughout the remainder of this course, so it's very important to understand this. In the next section, we're going to start taking a look at structs and lifetimes and continue building upon this idea of ownership, referencing, and borrowing. I hope you enjoyed this assignment and the 2 questions associated with it, and that you were able to complete both questions without any problem. In this video, we are going to go over the solution to both questions in the assignment. The first question is, create a function that takes one argument called val that is of type vector with the values 1, 3, 5, and 7. So we will create our function and we will call it checkVal, and it is going to be of type vector, so we know that, and it has values 1, 3, 5, and 7, so it is of type I8. And then inside of this function, check the first value of the vector and see if it is equal to 1. If the value is equal to 1, then return true, otherwise return false. So we know that we're going to need to return a Boolean. And so now we want to check if val of 0 is equal to 1. If it is, return true, else return false. So now up here we are going to create our vec, and we can use the vec macro for this. And we're going to have 1, 3, 5, and 7. So now we want to print out if our value is true or not. So we are going to call checkVal, and we will say on vector, and then add the value 15 to the vector. So we can do push 15, and then to confirm our results, we want to print out the vector. So will this code compile or not? It does not compile because vector does not implement the copy trait because it is not a simple type. So in order for us to pass the vector into this function and then still be able to use it after this function call, we need to pass it in by reference. That way the function down here called checkVal does not take ownership of our vector which we created here. So now if we go to run this, it will not execute fine because I forgot the mute keyword. Since we are pushing a value in, we have to make it a mutable variable. And now if we run it, it will execute perfectly fine. And this is a good segue into question 2. So create a function called add2, and this function is going to take one parameter that is of I8, and we're going to add 2 to it. Okay, so we'll say val plus 2. And in this case, we don't care about returning our value. So up here, we want to say let mute value equal to 2. And now we want to call add2 on value. And what I want to do here is now I want to say value is equal to 5. So will this compile since we are not passing in value by reference? So let's see what we get. So we have, I need to not return a value. So we get no errors when we try to re-access value here. And the reason to that, and this is going to answer the question of, do you have to pass the value by reference in order for you to maintain ownership of it inside of main? And the answer to that question is no, you do not have to pass the value by reference. There is a caveat for that, because you do not have to pass simple types that implement the copy trait. And we will talk more about the copy trait later on in this course. But for now, I want to open up this concept to you that certain values are considered simple. So integers are simple, I8, I32, I64, and so on. And it's simple because it is easy to copy those values. So when you pass, in this case, an I8 into a function, you do not, and I repeat, you do not have to pass it by reference in this case, because it implements the copy trait. So that is just something that I wanted to introduce to you now, and it's going to be something that we cover on later on in this course.